Hi, hello and welcome. Welcome to this short little video about an article on The Verge reported on by Nicole Wetsman, who is a journalist in health and how technology is used in healthcare and stuff right here at The Verge. It was something I stumbled on earlier this week and I want to share some of the main points with you guys because I think that the introduction of algorithms and artificial intelligence in healthcare, in like the general form of healthcare, in like hospitals and stuff, but also in psychology and psychiatry where I am situated in, is definitely something that's on the rise and it's one of the new frontiers in psychology and technology. I found this article to be like a very clear introduction into what the use of AIs and neural networks might mean for the healthcare world. It uses a concrete example diagnosis of something that we can help prevent, with the introduction of this new technological system, and I think that can encourage a lot of people to look at it with an open mindset and kind of accept this into the way we treat patients. Now, what is AI actually about? AI, or artificial intelligence, are these computer programs, right? And they suck in vast amounts of data. You need to input like a lot of data into those computer programs, into those networks, for them to learn what they actually have to do. And what they have to do is look at all that data and try to look for patterns, look for trajectories, and look for ways for the program to make decisions or help guide decisions or make predictions about what patterns might arise in real life data that is more lively and taken in the moment. AI is already used often in healthcare. It has been introduced in our system in a bunch of ways, but most of those ways are still very much unseen for the patients. They happen behind the curtains, and even the practitioners using these systems might not always be up to date about the basic functionalities of what such a system entails. And I mean, it's still in an early stage in the grand scheme of things, of course. This article is very recent, but it's still like a very basic way of the program being introduced, the AI programmability being introduced in healthcare. So its uses are still very narrow. A computer cannot yet replace a medical practitioner, and I don't think it ever should, but that's something I will come back to later. But either way, it helps to guide them in certain small decisions. For example, if it helps them like, oh, is the risk in this patient for this particular problem high enough for it to warrant us doing all these extra scans on her? If the risk is not high enough, they might save thousands of dollars. If the risk is high enough, they might be able to prevent life-threatening situations. Who knows? Now, what this article is actually about is about the Sepsis Watch program. This is a form of the AI, of the neural network, that has been used in a hospital somewhere in America, I believe, probably. And sepsis is actually a complication that can result from an infection, and that complication entails that your whole body will be filled with inflammations, and it could possibly be deadly. It could mean the end of you. The symptoms for the complication to arise, however, are very subtle and hard to detect, so the AI algorithm right here might help practitioners in early detection of the sepsis complication. The program sucks in a whole bunch of data from a hypothetical patient, for example, Alex. The input for the model can be that his age is, for example, this, his previous conditions are included, things like that, a bunch of static information, and it's easy to access. But the machine learning program, the algorithm, the AI functionality doesn't only rely on that static data. It relies on lively data as well. Data collected right here in the moment, like here, for example, the vital signs, things like blood pressure, things like oxygen levels, and how they change from second to second. We can of course not go around and do blood tests every single hour on our patient, because and on all the patients in the hospital that have a risk for sepsis for that matter, because that's just not practically feasible. And that's why the AI uses its capacities, its mathematical algorithmic capacities, to form its own patterns from limited amounts of data. So here you can see that when, for example, Alex would have only had 4 measurements of his glucose levels during the day, the machine is actually able to interpolate those points to make a connection between them, and it looks at the 24-hour pattern even though it doesn't have actual data points for that entire hour. And this is what machine learning and AI is all about, to find patterns in data. We will not go into the concept of neural networks too far in this video because that's not a topic and that would lead us into a dark rabbit hole. But either way, the main premise is that the neural network is like this combination, this consolidation, this is like this configuration of nodes, right? And every node has a specific input way and a specific output path. What those nodes have been trained to do is they have been trained to, as I said, look at data and make interpretations, make predictions about what might happen in the future. That training phase is something where they have just been fed like thousands and thousands of possible cases, and they have to like, the nodes have to learn themselves how to interpret that raw data and output like valid output that we might need for clinical outcomes. After that training phase, the nodes and the machine learning system, the neural network, should be ready to act upon lively data, where the lively data, as you can see, the glucose, the age, the oxygen levels, they are now the raw input for that neural network. And because of its learning history, it can look at that raw data from now, from right here in this moment, from our patient Alex, and it can interpret what this all means. The data gets fed through all of the nodes into the endpoint of the network, where it provides an output. In this case, in the Sepsis Watch program, the output is a number between 0 and 1. And that single number, just a singular measurement, can tell a practitioner all about how high the risk is that this patient will develop sepsis. Right here, 0.6, so they might have to watch out for it. And well, now I think that is really beautiful in some way, right? There is this very complex black box of operations happening inside of that computer that the practitioners don't really know about what is happening. Sometimes, as it was stated in the article, even people that develop these algorithms don't really know what's happening, but they just see the functionality and are satisfied with that. But all of that complexity aside, what we get at the end is one single simple number that can help us in clinical decisions. It's definitely a new frontier in healthcare and in technology, and it will make headlines in the future, I'm sure about that. It's already doing so in other fields like economics, for example, or economy is I guess the right term. And in psychology and psychiatry, it's coming up as well. It can help us predict treatment outcomes. It can also help us just select like the right treatment path for a certain patient based on its characteristics. There might come a time, who knows, where we can just input characteristics of the patient's nature and nurture, so of his biology and his genes and what happened to him and his upbringing and stuff like that. And the machine will be like, or the neural network will be like, well, based on this information, I would provide this treatment. And wouldn't that be beautiful? Now, it's not that we have to rely blindly on this. That's not what I think this technology should entail for the future. I think clinical expertise and experience cannot be just diminished or tossed in the trash. It needs to be like a helpful tool, but an extra tool, an addition, not a replacement of real human communication between patient and practitioner, in my opinion. And the main goal of this article was to kind of like change the public opinion about AI as well. Make people less scared of what it might mean for them that AI is going to be used in their treatment. Because when the word artificial intelligence, the words artificial intelligence are mentioned in a hospital, a lot of patients might be scared. They might think like, wait, will the doctor not come talk to me anymore? Is a computer just going to solve my problems? I don't see that working out fine. So just providing insights into what happens behind the curtains, behind the scenes, might help alleviate patients' anxiety about using these kinds of technologies. And as a very positive note to end off, it reduced deaths related to sepsis in the hospital it was used in. So it has an impact, and it can save lives. We just need to learn how to use it better. We need to learn how to communicate to our patients better and communicate in between different practitioners about what the system outputs, for example. It has a long way to go to become like a very, very practical tool in our day-to-day healthcare system. But I believe that in the future we will achieve a bunch of great things if we are able to introduce AI into healthcare in a beneficial manner. Hope you found that interesting in some way, shape or form. Special thanks to The Verge and Nicole Wetsman to shed some light on this subject, and I hope to see you in the next video. Bye bye.